I'm going to draw this patio out. We've got a garden patio made from identical square paving stones laid out in a rectangle measuring X stones by Y stones. Here goes. So all of these are squares. I've just, it's only a sketch. And then this is going to carry on until the very last stone. I'm going to get the same going down, and this is going to carry on again till the last stone. I haven't quite, maybe I should try and draw it to scale a little bit better. There's our patio, and we're told that it measures X stones by Y stones. So if I made the width W, then I would have, let's say this is Y stones along here, I'd have YW, and then I would have XW along here. Hey, next up, when we add a border of width 1 stone around the patio, the area is equal to the original area of the patio. So at the moment, the original area is equal to xyw squared, xw times yw. Let's look into adding this border around the outside. Okay, this is what it would look like. So the area of the border is going to be, well, now instead of y stones, I've got y plus 2 stones. And instead of x stones, I've got x plus 2 stones. But that is the full area, so now I need to minus that x, y, w squared that I had before. That will be the area of the border by itself. Now we're told that the area of the border is equal to the area of the original patio, so I can construct an equation. X, y, w squared is equal to y plus 2, x plus 2, w squared, minus xy, w squared. At this point, I'm going to cancel the w squared out. And you could have said at the start, to be fair, that the width was just 1, or you could have just worked in terms of the length, yeah, you could have made this 1, but I work generally, it's cancelled out now, and I'm sorry if that's made it more confusing. You can just go for it again, but just eliminate the w's and make it all 1. It won't matter. We've got ourselves an equation, and I'm going to add the xy to both sides to give 2xy. I might have to bring it back over in a minute, but let's just deal with one thing at a time. So then I'm going to multiply this out to give me xy plus 2x plus 2y plus 4. And that's going to mean that it's going to be I'm going to minus xy from both sides, minus 2x from both sides, minus 2y from both sides. But I'm actually going to keep the 4 there for reasons that I'm going to go into. This isn't, like, we know that x has to be an integer. And actually, this is an example of a Diophantine equation. And here's one way of going about solving it. We can try not to factorize fully the whole thing equal to 0. That is like a standard approach for quadratics, but here we have 2 unknowns, so it's not going to work in the same way. But it will still partially work because what we had before was very close to what we need. We had y plus 2 and x plus 2. But actually, now I want x minus 2 and y minus 2 because that will give me this thing on the left-hand side. Okay, because of course now I've got this extra term that I've had to incorporate. So I get xy minus 2x minus 2y, but I get a plus 4 in there as well. So I need to minus 4 to compensate. And I get x minus 2, y minus 2 is equal to 8. Now this might look, how do we solve this? You've got to remember that these are integers. And so there's only a few possibilities for getting 8. And it's going to be, I'm going to make a little table of values. So let's go with x minus 2 and y minus 2. And therefore that will give me my values of x and y. Right, first possibility is why don't I make x minus 2 equal to 8? Then that means that y minus 2 would have to equal 1 for them to both be integers and multiply to give 8. And therefore x is going to be 10 and y is going to be 3. This is one possibility that I've found. Second possibility, okay, more factors, I'm just going to decrease. It's going to go 4 and 2. So then I'm going to get 6 and 4. That would also work. Then I swap these around, 2 and 4. I'm going to get 4 and 6. So that it can be just the same kind of patio, but just a different dimension. It's just that because it doesn't say anything about that. It's still a different patio because it's different values of x that there can be. So that's my third option. And then I'm going to go with 1 and 8. When I add 2, I'm going to get 3 and 10. So I just swap those around. Now, technically, you could get negatives here. So let's just look at a negative. So if I had, say, minus 1 and minus 8, that would work. And if I then add 2, I'd get 1. But when I add 2 to this one, I'd get minus 6. And if you try any other negatives, no negatives will work. But just because x obviously has to be a positive number, it's a number of slabs. You can try it if you want some other ones like 2 and 4, but because you're only ever adding 2, you're not going to get anything that is positive overall. So we've managed to find 4 solutions, and that is the answer to this question. Well done if you managed that.